now work through some examples of finding sine, cos and tan of different angles, and these angles don't appear in the first quadrant. There is what we call a template. A template is nothing more than just a method that you can throw over all of these questions, and if you use this method or template and work through this method, you'll be able to work out the answers. So the template looks a little bit like this. Your first step is to do a diagram, and doesn't have to spend a lot of time, but just a freehand diagram, and that will tend to give you which quadrant the angle is in. Now that's quite important. So the diagram should indicate which quadrant. Your second step in the template is to convert the angle to pi plus and minus theta. We always work off the x-axis. So pi plus or minus theta, 2 pi plus or minus theta, so it'll be one of these. Now 2 pi is coterminal with 0 plus and minus theta. Now theta is in the first quadrant, so it'll be less than pi on 2. So it is an angle between 0, theta is an angle between 0 and pi on 2. I'll just go through the template, then I'll explain how all of these steps work within an example. So the third step is to decide if the trig ratio is positive or negative, and that will be from which quadrant it's in. And the last step, and we can also simplify. And the fourth step is to evaluate. So there are the 4 steps in the template to be able to work out a question like this. Okay, let's see how this template now we can put into action with this question. So the cos of 5 pi on 4. So the first thing to do is to draw a diagram and mark the angle in the diagram. So 0 is here. We always start off 0 going out on the positive x-axis, so that's 0. Now it is so many pi on 4, so it may help to actually go around and put what each of those angles are. Now because we're working on 5 pi on 4, it would be helpful to make all of these as so many pi on 4. Now this is pi, and pi over 1 is the same as 4 pi on 4. You can cancel those 4's down and you just get pi. So that's still just the angle pi. From here all the way around to there is pi, which is 4 pi on 4. And we're doing it over 4 because our fraction has got something over 4. If we had something over 6, we'd make all of these. That would be 6 pi on 6. Okay, so halfway is this one. So what's halfway from 0 to 4 pi on 4? Well, halfway to 4 pi on 4 is 2 pi on 4. And how much have we added from 0 up to there? 2 pi on 4. So to go from there around to here, we've got to add 2 pi on 4. So you've got 4 pi on 4 plus 2 pi on 4, so that's 6 pi on 4. Now that will allow me to determine where I'm going to place this 5 pi on 4. So not big enough if we get up to there. Still not big enough because we're 4 pi on 4. So 5 pi on 4 is less than 6 pi on 4, bigger than 4 pi on 4. So here is my 5 pi on 4. So there is my angle 5 pi on 4. So we've done that and we've worked out the quadrant it's in. Now we're after cos, and we'll put our CAST, our acronym. Cos is positive here, all trig ratios positive, sine is the only one positive, tan. So I'm expecting, because the angle is in this quadrant here, that we're going to get a negative answer. So step number 2 is convert to pi plus or minus theta, 2 pi plus or minus theta. So we work off the x-axis. So there it is there. So we can say that that is cos. To get around there, it will be 4 pi on 4 plus 1 pi on 4. So we go round to that, and then we go another pi on 4. So 4 pi on 4 plus 1 pi on 4 is 5 pi on 4. So we've done this step here. So we've converted to pi. 4 pi on 4 is just pi plus pi on 4. So maybe we should write it like that. You'll probably get away with eventually just going straight from this step to this step. So it'll be cos of pi plus pi on 4. Okay, I'll put that intermediate step in there, but I think most of you, after you've done a few of these, will be able to go straight from there to there. Okay, we have decided if the ratio is positive or negative. Well, we've seen that cos is the only, is positive in the fourth quadrant and the first quadrant, so over here cos will be negative. So then we write negative, and the steps are, once you've got it in that form, that we actually drop this part. We drop the sign, we drop whatever's written there, and we just write that angle there. So my next step is, we've already said that cos is negative there, we write cos again, and we just write pi on 4. So we've done that, we've done the simplification. Simplification is going from there to there. Okay, we've decided if the ratio is positive or negative, simplify. Now we evaluate, and you say, okay, pi on 4, that's one of our little triangles, and if we do our little triangle, it's pi on 4 here, that one's pi on 4, you don't have to write both of them, and you need to know that these two sides are 1, 1, root 2, and the cos of pi on 4 adjacent over hypotenuse, so that'll be minus, comes down, cos of pi on 4 is 1 on root 2. Now it is conventional not to put a surd in the denominator, so the way to get rid of that surd is to multiply top and bottom by the same surd as what is in the denominator, so root 2. We haven't changed the value of that because this root 2 is nothing, root 2 on root 2 is nothing more than the number 1. So all I'm doing is multiplying that by 1, not going to change the value, but what it does do, root 2 times 1, we've still got the negative, root 2 times 1 is just root 2 in the numerator, and we go the denominator, root 2 times root 2 is 2. So I've done the 4 steps of my template here, and we'll work through that one to get the answer of cos of 5 pi on 4. Okay, let's move on, do another one. So number 2, we're using the letters B, we want the sine of 2 pi on 3. Now, bear in mind also that you could be using degrees here. I'm using radians, and I think you're going to use radians more and more as you work through these courses at university. You know that pi is 180, so 2 pi on 3 is equal to 2 times 180 on 3, so that goes into 180 60 times, so 120 degrees. So you would use the same template even if you're in degrees. Instead of pi here, you'd use 180, etc. So here we've got sine of 2 pi on 3 is equal to, now we draw the diagram. We're working in 3, so we got 0, this will be 3 pi on 3. Now halfway across will be half of 3, which is 1.5 pi on 3. And if we add that, that'll be 4.5 pi on 3. So we've gone 0, 1.5 pi on 3, which you can see 1.5 on 3 is still pi on 2. So 90 degrees is up there, 3 pi on 3, 4.5 pi on 3. So where are we going to put 2 pi on 3? So it's bigger than that. It's not as big as that, so it's out here. So it'll be up there. So there's my 2 pi on 3. We then put our CAST. So because we're working in this quadrant, it'll be pi minus. So if we go back to our template, it'll be pi minus something. So it'll be sine of 3 pi on 3 minus 1 pi on 3. 3 pi on 3 is pi. And if you take 1 pi from 3 pi, you get 2 pi on 3. So we get back to our answer. Now, looking in the second quadrant, we know that sine is going to be positive. So it'll be just sine. We then drop this part. So it'll be sine of pi on 3. Okay, so sine is positive, so we don't have to worry about that, and sine of pi on 3. So we've converted it to that. We've decided the ratio is positive, we decided it was positive, and then we simplified. So we've done step 3. Now we've got to evaluate, and you say, all right, pi on 3 is also one of our triangles, pi on 3, pi on 6, and this will be 1 to root 3. And the sine of pi on 3, opposite over hypotenuse, so that'll be root 3 on 2. No need to rationalise the denominator because the third is in the numerator, and that's quite acceptable. Okay, let's do one more. And we've got C, the tan of minus 5 pi on 6. We draw ourselves a diagram. We've got 0. Now it's on 6, so this will be 6 pi on 6. Halfway from 0 to 6 pi on 6 will be 3 pi on 6. So that's the angle up there. And the angle down here, if we've added, each of these are going to be 3 pi on 6. So that goes 3 pi on 6, 6 pi on 6, 9 pi on 6. And if we were back there, that's the same as 12 pi on 6. And that's 2 pi. So 0 and 2 pi are back at that point there. All right, minus 5 pi on 6. What's the significance of the negative? The negative, this is the positive direction for angles. And if we want the negative direction of angles, we go back this way. So we know that when we go through one quadrant, we've gone through 3 pi on 6. So if you like, we've gone negative 3 pi on 6 there. And if we go all the way back there, that's negative 6 pi on 6. So those are the same angles. If you go this way around 6 pi on 6, you've really gone around pi. If you've come this way and go back this way, you go negative 6 pi on 6 or negative pi. You still end up at the same point. So negative 3 pi on 6 is coming this direction around to there, and negative 5 pi on 6 is going to be somewhere in this quadrant here. So there is negative 5 pi on 6, starting there and going in that direction. That is the same as if you've gone from here all the way around to there. So to get to that one, it is the same as, and as I say, we're working always off the x-axis. So we've gone 6 pi on 6 plus another pi on 6. Because this is minus 5, this must be pi on 6 in here. This little angle here is pi on 6. Because this is negative 5 pi on 6, and then that's negative 1 pi on 6. So to go all the way around there, it'll be tan of 6 pi on 6 plus pi on 6. That will get us 7 pi on 6 is like going from there all the way around to there. 6 pi on 6 plus another pi on 6. Okay, so we've got that. Now we're going to, so we've got it in working off the x-axis, 6 pi on 6 plus that is fine. We then put our CAST down, CAST, and we say, right, what quadrant are we in? We're in this quadrant here, and in this quadrant tan is positive. So we put positive tan. We don't have to put the positive because it's understood to be positive. We then drop this bit, including the sign there. So it'll be just tan of pi on 6. And now we evaluate, and we've got our little triangle up here, and we've got pi on 6. So pi on 6 is up there, and the tan of pi on 6 is opposite over adjacent. So tan of pi on 6 is 1 on root 3. And just like before, we rationalise because we've got a surd in the bottom. We just multiply top and bottom by root 3 on root 3. That is 1. So we're just multiplying it by 1, but we're just making it look a little bit prettier. Root 3 times root 3 is 3, and root 3 times 1 is root 3. And there's our answer.